Grazie, Monica. And since some Italian music was played, very good, very good. I'm glad you appreciate some Italian music. Now, when I visit Colombia next few weeks, uh, I want to learn more about Colombian music and what's going on these days in terms of pop music. So um, also I welcome any recommendation for places to visit. I've been to Bogota before, but hopefully I will see other places as well. Oh, Sebastian. We went. All right, so let's start with our third case of the day. So we have a very busy morning. So what we're going to cover now is a case that will be less challenging from an analytical standpoint, and more fun and intuitive in some ways, but just equally stimulating as the other cases that we have seen. Jorge, I can invite you practice rock climbing close to Bogota. I'm scared about heights. I'd be happy to come hiking in the beautiful mountains, but rock climbing, Oh, hi, Melo. Oh, yeah, Giovanotti. Very nice. All right. So, you know that in business, a lot of businesses have to do with online reputation. They have to deal with online reputation, especially when you are doing online commerce, or you have perhaps a restaurant or a club, a music club, and you want to hear how people are doing. Because before people try new places or try new products, they go and check reviews. In this case, we are talking about Yelp. Yelp used to be especially popular a few years ago as a place to leave reviews. It's still active, it's still popular, but now, you know, Google reviews, for instance, it's just as popular. And so why is it important to understand what's going on at the reviews level? Well, first of all, to know how you are doing, if you're making your customers happy. And also, reviews can be used as a tool to improve your situation, because you can attract customers actually by having good reviews. So it's not just about having a metric of customer satisfaction, but also is also a metric, a marketing tool. And of course, this is still data. It's not the data in the format that we are used to, in the sense that it's not typically is not quantitative data. Yes, you can look at the number of stars, but the reviews can tell you much more than 1 star, 2 stars, 5 stars. And the question is, how do we analyze data that is textual, that it comes in the forms of words? How can we quantify, extract information, and then ultimately try to quantify it in a way that is usable? So this type of data analysis takes the name of natural language processing, or NLP. And in this case, one of the goals is to make yourself familiar with a library, NLTK, which is a library that can incorporate many natural language process algorithms. So you will learn about to use and to analyze strings of words, vectors, tokenizations, and parts of speech tagging to address your data analysis need. Now, the problem is complex because our language is complex. The way we talk is always evolving. Each one of us talks in a different way. We use language in a very personal way. Just like the colors of a painter, we use words in a completely unique way. Of course, there are similarities. There are constructs that we tend to respect even when we make mistakes while using one language or the other. And of course, there are many differences in the ways that There are regional differences, dialects, slang words, and so on. And analyzing everything in a complete way, very realistic way, is extremely hard, because although computers have gotten better and better at understanding human language, think for instance about Siri and all the different electronic digital type of language translators, it's still very hard to extract information for very large, massive amount of reviews and so on. So we need to learn first the fundamentals. So your business context is that you are a business consultant for a small and medium-sized businesses with large number of customers. Some of these businesses can include restaurants, clothing stores, online distributors of hobby equipment, or but I mean, the choice is very vast. You can have disco clubs, you can have electronic stores, or even you can have some digital platforms, social media. Imagine that you want to make new friends or find a new romantic partner, and you want to use an app. You want to know about if the app is reliable, if it's safe, if it's respectful. All of these features are relevant. And your goal as an analyst is to help your small businesses understand what factors are driving positive and negative comments. So what are your customers appreciating, and what are your customers really, really disliking? Many times customers do not like to leave feedback, and they don't have the time. Sometimes you find that only the people that like to give feedback are only the ones that have something negative to say, because they are really, really upset, and then they go and write online a bad review. But perhaps there is a selection bias. At the same time, there are some businesses that offer incentives for positive reviews. Even when you go on Amazon, sometimes you see reviews, they make you wonder if they are realistic or not. However, it seems that in this case, you are part of your businesses want to know what they're doing well and what they can improve on. Okay. So as an analyst, you want to have a service that allows businesses to quickly obtain useful summaries, because if they are getting a lot of reviews, they might not have somebody that can go and read them all and summarize all the information. So they want probably an analytical tool that can summarize and say, okay, what are my customers saying about my business? So some questions that you might help answering are, what are the most important factors driving negative reviews? Or did a recent policy change improve our reviews? So customers were complaining about something, we tried to make an improvement, is it working or not? Herman is suggesting, identify fake reviews and counterfeits. Oh, thank you, Herman. I never heard about this. Interesting. So your business problem will be to wrangle a data set of text reviews and engineer relevant features in order to facilitate subsequent analysis and model building. That is, how can we make our reviews more similar to data? How can we extract things that then we can use for analysis? And your analytical challenge will be that the data is highly unstructured, so you will not have a bunch of rows and columns. And so you will have to do some pre-processing. And that's where we use natural language processing to process the data and generate new features that can be used for analysis. So first of all, we need to learn about these tools, and we'll introduce some basic steps of pre-processing. So we'll talk about word tokenization and text visualization. Some of the text visualization tools you might be already familiar with. And then introduce key tools in feature extractions, such as n-grams, 1 gram, bigram, etc., count representations, and stop words. Then leverage these tools to perform exploratory data analysis. And finally, look at pure text wrangling tools like regular expressions. So it's a very dense case, will not be necessarily analytically challenging. However, it has a lot of content that I really encourage you to take your time to digest. So one of the biggest users of NLPs has been Google. That sometimes when you type, tends to give you to either complete the word to the most intuitive way, or when you start a search and maybe the search is not high quality, Google suggests a better search key that can help you visualizing better results. And this is a form of an automatic translation of text. And another example is when you put the automatically generated subtitles for YouTube videos. Some of them are very funny in the sense that at times they are really not capturing exactly what people are saying, but a lot of times they are. Or also the language to text type of translators. Right now we have a live transcription, closed captioning, that probably is putting on screen something that I'm saying. I'm not seeing it, but you are probably. And Google also helps with suggestions when you're writing emails. I don't know if you use Gmail, but sometimes you get help and it helps you typing faster. And you say, oh yeah, that's actually good. I'm gonna use it as is. And you know, so you can actually use it. Sebastian, of course, NLP tools exist in all sorts of languages, of course. For some languages, they might be more developed than in others, just because maybe there are more people working on them. Yeah, of course, also it really depends on the, you know, the type of characters and fonts that you're using. So I know that even for Chinese, NLPs work very well. They are just a little bit different in the way that words are used and fonts are used. And so you can use it for all types of natural languages. Even for programming languages, there is this type of tools. So when I'm coding in R gives me suggestions. Sometimes if I mistype the name of a function and so on. So yeah, there is a lot of it. You can be used for any language really. So it can be used for many different things. It's a way to build a bridge between the machine and the human beings. So we use NLP to help computers understand human speaking. And for that, we use audio processing to translate between different natural languages. Think in terms of Google Translate. That's text translation, reasonably simple. Automatically apply labels or categories to natural text. Or to have computers read aloud. Think, for instance, Kindle and TikTok. You know, on TikTok, you can type in sentences and then you have a voice that adds to your videos. So that's a way of natural language processing. So it's a huge field, and the tools are different depending on the task that you are investigating. So we are going to focus on some of the common aspects of these different areas. And there is also some controversy in terms of the relationship between NLP and machine learning. No, Alberto, I'm not a TikToker, but I know about TikTok. A lot of people think that NLP is machine learning applied to words, and it's not quite true. NLP has characteristics that make it intractable for some naive applications of machine learning. If you try with neural networks, you will not end up really with very good results. You know, neural networks can work very well with images and other types of data, but not quite so much with natural language processing. So what are the challenges of natural language processing? Well, first of all, high dimensions. Think about it, we have a limited number of fonts, but think in terms of the number of words that are in the dictionary. We're talking about tens of thousands. And think in terms of the combinations that these over 10,000 words could be used to make sentences or to actually write paragraphs or text or books. Think in terms of a large novel like War and Peace. It has over 3 million characters. How do we treat data of this type? Do we treat it as just a sequence of spaces and characters? Or we treat it just in terms of words? And that's, the dimensional space is so large that machine learning would not be appropriate. For instance, a machine learning approach would get lost in understanding that don't and do not mean the same thing. Of course, I'm not saying that machine learning cannot be applied to data that have been already processed using natural language processing. Indeed, there are still applications of machine learning data. However, the basic steps that we will have to implement will require their own set of techniques and tools, right? How to get same classification to different ways to write, for example, if X and Y, is it possible? Well, yeah, I mean, that's a wide statement. I'm not sure, like, you know, the case that you are thinking. And Google new AR glasses translate language in real time. Wow. If that's true, that would be impressive indeed. Does it translate in terms of visuals? Well, that could really help, for instance, people that have hearing problems, and perhaps they have to interpret the just the labial and, you know, the mouth sound. So, you know, it's very interesting. So the second question is that text is context specific. Just because a word is present in let's say a word has a negative connotation, if I say the word bad, if my review contains the word bad, does it mean that I'm criticizing the product? Or maybe I wrote a sentence that says, oh, the ice cream was not bad at all. So, you know, the context is important. It's not just about the value of the content of a word, but it's also the context in which it's used. Or think in terms of synonyms for the same word. So think in terms of different uses of the same word. For instance, the word queen can mean many different things, like, you know, the head of a state, like the Queen of England, or a size of a mattress. Here in the US, you have king size, queen size, etc. But also you might be talking about in the chess piece, or the bee in a colony of bees, or if you're referring to somebody as a queen because is a particularly prestigious or great actor or singer, etc. So there are many different uses of the same word. And, you know, you will have to consider the use. Oh yeah, Sergio, Queen, the rock band. Queen can be a name too, absolutely. There is also, I think that Queen is also indicated yeah, there are a few more uses that I can think. Yeah, she can move in any direction. So one of the the things that we have to take into account is pre-processing and standardization. Standardized text involves many different sub-steps, and some of them include correcting simple errors. For instance, different texts might use different encodings, and you will find that funny characters that have been imported wrongly, because maybe somebody was using a different type of keyboard. Think in terms of vowels that have stresses, that have accents, and perhaps you don't have a keyboard that has all of those accents, or you have to use key combinations and you just put it unaccented. For instance, when I'm learning Spanish, sometimes I forget to put accents, and Duolingo tells me that the sentence is correct, but it warns me and says, hey, you forgot the accents. So it's that type of little flaws that need to be addressed. But also creating features like labeling nouns and verbs in a sentence, replacing words and sentences altogether. For instance, some of the words might be spelled in a different way just to convey a particular emotion. Like if you write bravo with many O's at the end, or so all of those need to be fixed in order to standardize the information and not think that they are different words. So standardization is a form of similar to data wrangling, and we are fixing errors, removing outliers, and transforming features. So in this sense, the spirit is similar to what we do with quantitative type of variable. And the details, though, tend to be more complicated. Oh, yes, abbreviations can be also one factor. Excellent comment, Karen. OMG, ASMR, LOL, ASAP. So, yeah, of course. So the library that we will use in Python is called NLTK. And you have a link here that you can click for more information. And you can do pretty much everything that you need for a basic use of natural language processing. You can use it directly in Python, and it's very easy to read, has great documentation, so please check it out. Another more recent library that has been published for Python is called SpaceC, with a capital C, and it's focused more for the industry use than on education. It's described as being opinionated and having strong preferences in terms of the algorithms that it suggests to use. So the source code is a little bit harder, and this is why for education purposes we will use instead NTLK. Yes, of course, Laura. Strict language is also a variation of language that is very frequent in text, and we should definitely account, for the more colloquial expressions and slang. So main text wrangling pipelines start a little before we do initial cleaning, and there could be some initial steps. For instance, running a spell check or autocorrect on a document, it can help really decreasing the amount of noise. With noise in text analysis, we mean basically typos or words that are used inappropriately. They are similar to existing words, so they might not be marked as a typo. However, they are either grammatically incorrect, or they are, or you are spelling something differently, thinking that you are meaning a certain word. And sometimes the equivocations can be actually funny. There are many of these false friends in Italian, in French, in Spanish, and so on. Okay. So let's start looking at the data set of Yelp reviews. Each review consists of a number of different features. Okay, so we have a review ID, and that's basically an identifier for that review. Then a user ID, because the same user can have multiple reviews, right? Then we have a business ID, and this is the business that is the target of the review. whether it's positive or negative. Then is stars. How many stars? The date, the text, where the real action is, and whether or not the readers found the review useful or not, whether they found it funny or cool, you know. So there are some initial reactions from the readers. As I said, most of the action is in the text part because that's the part that we really want to process. The other ones we are already able to analyze. You know, for instance, we know how to analyze data that are semi-quantitative, like the number of stars, or binary when it's useful versus unuseful, funny and cool, etc. Okay. So let's start importing everything that we need for today's case. Okay. So we are going to import NLTK. We download the punctuation and the stop words routine. Of course, we're going to need pandas and NumPy and string and plotly, especially for graphic visualization. And then we are going to have from LTK stem, we import Porter stemmer. So here is everything that we are going to need for today. So let's open the data set and let's start seeing what it looks like, right? We always do this step before we dig into data analysis. The file is called sdata.csv, and it has 5,000 rows. So we have 5,000 reviews, and this is what it looks like. So we have some awfully unreadable review ID and user ID and business ID. Of course, we want to keep this as we don't want to identify anybody on the data set. So we have these long strings that don't mean absolutely anything. Then we have the review in terms of stars, the date, the text, and then the reaction. Now we see that the first 5 reviews, nobody found them neither useful nor funny nor cool. Probably people have not a chance to react to it. And then of course we have the text of the reviews. From some of the words that we are seeing, yeah, of course, there are many neutral people as well. What would be interesting would be also the number of people that actually visualized that review. You know, sometimes the reviews, you only have the few rows and you have to expand on it. That's an interesting metric to see how many people actually clicked on it. And then, of course, you know, from some of the buzzwords that we are seeing in the text description, we can tell right away that this is probably a restaurant because it's talking about menu, chocolate almond croissant. So it's either a bakery or a restaurant, right? And if you want to just focus on the text and you start displaying it, you will start displaying basically the strings of words and sentences that form each review. So just like structured data, like in a comma separated variables, data is formed of features. Text data is composed of sentences. So the first step that we need to take is to isolate the sentences, and this is called sentence tokenization. It means splitting a long document into its bricks, okay? So the bricks of a house are akin to what the sentences are part of a larger text, okay? And we say, well, anytime that we see like a period, we say that the sentence is over, but is it really the case? Because the period is used in many different ways. For instance, you're writing a website address and you use .com, or you are using suspension phrases like ... Or when you are using, let's say, as a form of abbreviation and you write miss and you put the dot. NLTK can help you actually to automatically tokenize the functions. Now, the NLP literature uses common words in technical ways. For example, a document means any standalone string that might be a part of a larger collection. For instance, the chapters of a book, the articles of a newspaper, and so on. And they can be a part of a larger body of documents. For instance, a book might be a part of a series of books and so on. We also look, though, at the word document, not just in a classical sense, but also to talk about a collection of tweets, if you are talking about Twitter, or a collection of reviews, like the one that we are working right now. So what we are doing right now is the analysis of a document, okay? Let's start with exercise 1. Give an example of a question we might be able to answer with this sort of data, and another question we need additional data to answer. Assume for now that all of the reviews are coming from one business. So we assume that we are focusing reviews for one business. So let's go this together, and then you can tell me what you think. So a human reading might be able to figure out the most appreciated features of a business by looking for features that are consistently praised. For instance, is it the quality of the food? Is it the ambience? Is it the customer service? This is something that probably we can understand from a review. And then we can also look at some of the features that appear more often in positive reviews. Well, of course, we have to ask ourselves, what does it mean to be a positive review? And how can we categorize a review to be positive? That's not obvious. What can be hard to decipher might be, for instance, if you want to compare if the business is more appreciated by locals or by tourists, or whether the business is more successful in the evening or in the morning, and so on and so forth. So here, each document is a single review. So let's take a look at the first document in our data set, and we tokenize it. So we are selecting from all reviews the entry 0, which is the first row in the first row of the data set. And let's take a look. Super simple place, but amazing nonetheless. Just this would make a human understanding that the place this is a positive review, right? And then it adds, it's been around since the 30s and they still serve the same thing they started with, a bologna and salami sandwich with mustard. Staff was very helpful and friendly. So there are things that are commenting about the fact that they have a customer base that goes there for a product that they really like. It's been around for a long time. And they are praising also the fact that the staff is helpful and friendly. Now, how do we tokenize the sentence? First of all, the document that we are focusing our attention is this one, the first entry in the text, in the reviews. There is a function that is called send tokenize from the NLTK package that allows us to do the processing of this document. And it breaks it down in sentences. So it's a little for loop that will print the sentence in the document sentences, okay? And indeed, it gives you, yes, Nicholas, it gives you a list. So the first sentence, super simple place, blah, blah, blah. The second sentence has been around since the 30s. And the third sentence, staff was very helpful and friendly. It may seem like the sentence tokenization to be simple, but remember that the period can be used in very different frameworks. In this case, in this case, it was only used as a sentence breaker, but it can be used in other examples. So for instance, Tom wrote a letter to Mr. Pond, his uncle. I am arriving on Monday, another example, of Jan. Please meet me at approx 5 p.m. Here we see like there are many dots. If we try to tokenize it ourselves, so we are smart tokenizers, we will see that the sentences are these ones, right? However, we can see that there are several periods. So we have to consider also that the different way that people use abbreviation and punctuation can make this a definitely non-trivial task. Now, of course, the NLTK has several, to answer some of the questions, say, hey, what does it do to recognize sentences? Well, there are more sophisticated ways. There are a lot of exceptions that are considered. For instance, there might be some exception words like, all the months, all the days of the week, the appellatives like Mr., Miss, etc. Those are probably entered in the bag of words of the natural language processing and identified as a word itself. So the period in that case is interpreted correctly, okay? And then there are people that don't use punctuation. And for that, really, you need to get into more sophisticated processing tools. And yes, to answer your question, Juan, and Francisco, definitely there are tools that are sophisticated enough to tell that that's a sentence, even though a dot is not used, okay? A period is not used. Suppose that we were successful at tokenizing sentences, and now the next goal is to tokenize individual words. Why is that? Because words contain a quality, right? And we might want to have a basic understanding of the type of text by looking at the quality of words that are used. How can we tokenize words? Well, typically we have either a space, some exceptions like compound words where you have an hyphen that connects two words. And of course, a comma or a colon or semicolon, they separate words, right? There are sometimes people that forget to put their space, let's say, after the colon. The comment is, so the word tokenization can be achieved by using the function word tokenize. So we're going to run this through all the sentences, okay? And then we are going to tokenize sentence by sentence of the words. And here we have the list of words that is contained in the first sentence, the list of words that is contained in the second sentence. Call for a reservation, this is another sentence, and so on. So if you have loaded the data set, try to conduct an exploratory analysis of the sizes of review. Find the shortest and longest reviews, and then plot a histogram showing the distribution of review lengths. And start thinking about it. Does a long review tell you something about the opinion of the customer? Right, Danielle, this particular one is not. And in fact, I'm really glad that you tried with that sentence and you could see why it didn't work. Oh, Fabian, excellent. I completely agree with you. That's my impression too, that people really like to take time to write a long review if they feel really strongly about that place. If if they think either that it was extremely good and so you're very grateful and you want to give a very good review and then you spend the time, or it was really awful and then you really, really want to complain about it. So I think that you are right, that, extreme feelings lead to longer reviews. What about exclamation points? Do you think that people use them more when they are super happy or when they are super upset? Maybe when they're super upset, you can find more words in all caps. All right, so let's take a look at the length of the reviews. And we can see it together. So we are going to apply to all reviews the length after we tokenize the sentence. So we want to extract the words first before we can count them, right? So we tokenize each sentence one by extracting the words, and then we look at the minimum and the maximum. So the minimum is actually 6. So the shortest sentence in these reviews has 6 words. And then we look at the maximum. The maximum is 1,105 words, which leads me to believe that this person clearly did not write very well and probably put no punctuation, and that most of the text was considered one sentence. So this is the example of the one. This is the review that had the maximum word length. Excellent job from all of you that were able to perform the histogram. We're going to see it very fast. And indeed, now, depending on the number of beans, you might see slightly different plots, but that doesn't mean that yours is not correct. In this case, we selected 25 beans. So, for instance, it looks a little bit more detailed than the one that Santiago produced, but they are both acceptable. So we can see that the majority of the sentences tend to have between 0 and 200 words, which, if you ask me, a sentence with 200 words is still very, very large. So, but of course, there are many longer ones. Another way to visualize information about our data, about our text, is word clouds. They can be used sometimes, but they have also to be picked with a grain of salt. You have to be a little bit careful not to read too much into it. So we need pyplots from matplotlib, and we also need to import word cloud, and we are going to join all the text from the data, and then create a figure for the word data. Notice that here you have that words tend to be made of different sizes. The fonts are different sizes depending on how popular they are. So what are the words that are most common here? We have one, we have place, we have food, really good, so but also time. And so these are the words that are most commonly encountered. So word clouds, they are visually appealing. They can tell you something. Oh, Hernan, the library depends on the language. Yes, because different languages might use different punctuation. So they might, but I'm sure there are different versions. So word clouds, again, you cannot read too much out of it because they cannot tell you too much, and they're not a full proper natural language processing tool, and this is why a lot of people don't like to use them that much. Also, it's just looking at the sheer frequency of use and is not considering how the word could be important or not. So inverted word, I don't think that inverted word has a particular type of meaning, quite honestly. I think that is just to fit all the words in a space. So I don't think that orientation has a particular importance on a word cloud. So exercise 3 asks you to write a function called word cloud rating that constructs a word cloud from the subset of data that exhibit a certain star value. So you want to have a word cloud, let's say for 5-star reviews, for 4-star reviews, etc. And it's asking you though to do it specifically for the 1-star reviews. So probably, as an analyst, you want to concentrate more on the customers that are not satisfied rather than on those that are satisfied, because it means that you're doing well already, right? For those. So you need to understand where you can improve. So try to, let's see if we can try to display this word cloud. Oh, Adrian, I'm sure that, as I said, for Chinese and other languages, they use ideograms and different fonts. The exceptions will have to be established beforehand, but also the concept of sentence might not be there. So while it might make sense to use word tokenization, the sentence tokenization might not be always needed or appropriate. So we have a long case, so we're going to go a little fast here. But the main goal is, first of all, start subsetting the data depending on the star value. Remember, you want to look at 1-star reviews, right? So you need to filter them according to the 1-star review. And actually, the function can be done in such a way that it can be generalized, right? So the star value is one of the possible values that it can take, and basically the function will allow to pre-filter the document based on the star value, which is one of the arguments that you have to decide, and then of course you can prepare your word cloud. And this is the word cloud for the one sentence, for the one word, sorry, for the 1-star reviews. Notice that many of the words are don't sound even negative, right? Food, one, place, order, service, good. Oh, probably they're saying this place was not good at all. Minute, even, asked, told. So, the words might not be telling you the full story. The word cloud might not be telling you the full story. And in fact, the word good seems to appear quite frequently on the negative reviews. Investigate why and what is a reasonable explanation. Yeah, as I said, can say this place or the food is no good. Manager, yeah, I asked to speak to the manager. But also, you know that sometimes reviews are written by opponents. So you might find a negative review that says, oh, this restaurant is really terrible. You should go to the place down the street, which is actually very good. So the word good appears on the negative review, but is referring to another good place. So there are plenty of possible explanations. So let's look at the first 5 reviews that contain the word good. So how many types of font sizes are there? I think that it's a predetermined font size, but it's all about making it fit into that shape. Oh, Louis says very smartly that we can also have positive comments in a negative review and say, okay, while I appreciated the good look of the furniture, the food was disappointing. So let's check some examples of negative reviews with the word good. New York City, we really had good ramen. Listen, though, that time you disappoint me. The thought of it sound good. Furniture might be good. Price center, and it was good. Always good experiences. He said it was good in quotation marks. Notice that good, when you add quotation marks, becomes completely the opposite of what it means, right? When you say good reviews, oh, I heard that this place had good reviews, but I came and I didn't like it, right? So the way that it works is you have to run a for loop, in this case, through all the reviews. And the function that you can use for this is called review.find. It's called find, and you attach it to the items in the review. And the word that you're trying to find is good. So the context is necessary to understand better. So let's talk about the important concept of n-grams. N-grams are basic structure that put words together, essentially. A 1 gram is basically a word, right? So instead of looking at just one word, it might be useful to look at blocks of 2 words or more words. So the first multigram that we can consider is the bigram model, which looks at pairs of consecutive words. For example, the sentence, the quick brown fox jumps over the lazy dog. The bigrams would be the quick, but also quick brown fox, fox jumps over the lazy dog, right? All of those would be the bigrams. Trigrams would be, in this case, would be the quick brown fox. Brown fox jumps. Fox jumps over the lazy dog. So those are the trigrams. Joan, how do we know that the sentences are negative reviews? Because we only selected the ones with 1 star. And only one with 1 star, we expect that they are negative. So what are the advantages or disadvantages of looking at n-grams compared to looking at words individually? First of all, it keeps the structure of the overall document and the order, and it helps to put words in context. And the dimension is, of course, larger. Okay. Maria, yes, it's also possible that they misunderstood the rating system, of course. A mistake in entry can always be, or, think one can also write the wrong review. Somebody might write, this place was good, and while forgetting to write the word not. So of course, an error can always be possible. Well, yeah, as David, that's also the comment that also Maria was pointing out. What happens if an opinion has 1 star, but it's actually positive? Well, that seems to signal a misunderstanding in the rating system, and then probably can be either rectified by text analysis. We'll see how to perform some of it, but also by human intervention. Okay. The waiter was good for nothing. Oh, Juan Pablo, 128 gram ounces. Very nice. The last challenge is the dimension is much larger because the word can be repeated multiple times, right? So there are more n-grams than there are words. Think, for instance, we said War and Peace that has 3 million characters, which translate to several 100,000 words. But also, if you consider all the possible set of bigrams, can be just as large as the number of 1 grams to the square. And that's 100 billion possible bigrams. So if classical machine learning models, they are not good enough for training a 3 million characters, they definitely cannot train a model that has 100 billions of dimensions. So the most careful and sensitive way to proceed is extracting as much value out of words before we dwell into more complex structures. So we are going to start now by looking at some interesting features of our reviews. In particular, we will look at count-based representation. Basically, they are representation that are based on counts, and then word embeddings. And we'll see what word embeddings are. Word embeddings are very commonly used, and they can be combined indeed with machine learning methods. And they actually have improved several of the tasks. Let's start with count-based representation. These are techniques that help you understanding how frequently certain structures occur. And we are going to start, of course, with single words. So we're going to look at Word document co-occurrence matrices, where the WX entry of the Word document is set to 1 if the word W occurs in document X and 0 otherwise. Okay, so we're looking about all possible reviews and whether or not that word is present in each one of the reviews. So let's create a Word document co-occurrence matrix by use the function count vectorizers. And we have a series of words here. And notice that we have 5 rows. Well, this is just the top of it. And 23,768 columns. Okay, so notice that these words are not present in the first 5 documents. So we would have to go and scroll over to the rest of the spreadsheet to see the other columns. But again, there are tens of thousands. So let's try to find the high frequency and low frequency. So the top 1% and bottom 1% was in the reviews overall. So import the counter function from the collections class. This function can help us counting how many times a single word is used. And this is a possible solution. First of all, we want to join all the reviews, okay? And we use the function that we used before, which is called word tokenize. So we tokenize all of them, and then we use the function counter to tell us the length of the frequency, essentially. Okay. So these are the so the length of the frequency of the word frequency is 32,000 words. So if we look at all the reviews, there are 32,000 words. So if we want the top 1%, you know, we have to divide. Yeah, we basically want to have about 500, 450, 450 words. And considering also that some of them are not really words, so we have to be a little bit careful. So for instance, the most common item that in this case is tokenized as a word is the dot, and then the, which is the article. So a lot of them, they are not really meaningful. Notice that you have a lot of articles, prepositions, verbs. It's not really pronouns. There are some verbs, but yeah, before you actually come to something descriptive, yeah, you find place, you find good, you find food, etc. And yes, we're going to talk about stop words, Mauricio. Yeah, why 463? Well, because here we are also considering that some of them are not words, so we want a little more than 200, than 50, than 320. And the last ones are the following. Notice that some of them are really, really misunderstood words. So these are the ones that were used only one time. And there are some of them that say overpriced, underpriced, heaping, seafood, surrounded, unenthusiastic. So some of them appear only once. And now we do the same for the bigrams, but we're going to do it only for the first 5 reviews because it can take very long. And the first ones, these are the bigrams. So you have things like super simple, simple place, but amazing, amazing nonetheless, and the old, and there are many of them. Fabio, can we analyze emoticons as well? Yes, of course, because keep in mind that emoticons are nothing but lines of code, so they can be thought about in terms of words. Think, for instance, about how we use shortcuts with our keyboard to make emoticons, right? If we do the column and the right parenthesis, we have a smiley face. So yeah, we can convert emoticons and text back and forth. Sorry, Carolina, you're sad. Now let's write a function that is called top k n-grams for printing out the top k n-grams. Use the function to get the top 10, 1 gram, 2 gram, and 3 gram from the first 1,000 reviews in our data set. So this is mostly an exercise of, you know, once you know the functions that you need to use and how to extract the top 1%, you might, you just need to code a loop, okay? So you might design a function that takes arguments for the word tokens that you are using, the n. This establishes um, the size of your, if you want a bigram, so it can be a 2, it can be 3 grams, it can be a 3, etc. And K is the how many top you want to retain, right? So we first get the n-gram list, then we find how many there are by using the counter, and then you use the most common, the n-gram counter most common, which is the one that we saw before, and we can print it. So the top 1,000 reviews, you will have data text. You will select just the first 1,000 because you want to use only this part. You want to join all the text from the 1,000 reviews. You tokenize the words, and then you apply the function that you have created to get the top 10, let's say, single-use words. Not much of interest here, right? Because you have periods, the, and so on. All these words are not telling you much. However, if you do the same thing with the top 2, you see that, you know, fragments that start to become a little bit more evident. But even with 3, you see that, you know, we are not there yet in terms of extracting something meaningful. And this is why we need stop words. You might have noticed a pattern that show up in the top 10, 1 gram, 2 gram, and 3 grams. In particular, there are common words that appear in every sentence of the English language, like pronouns, prepositions, articles, punctuation symbols. And these are uninformative. They're not really informing us enough. So this is why we need to pre-process the data by considering the stop words. So usually it's as simple as providing a list of stop words to the machine that tells us, hey, anytime you run into this, stop. That's not a word. For instance, in other cases, it might be more appropriate to use other stop words like the word burger when analyzing reviews of burger chains. Just because it happens already too many times, it doesn't really help you understanding how your burger restaurant is doing just by knowing that people are mentioning burger in their review. Okay? So, and the NLTK library has a standard list of stop words that you can download by typing NLTK download stop words, and you find words that are so commonly used that you will not consider them. Notice that those word clouds that we were visualizing before, they were filtering for this. In fact, most of the word choices on that word cloud were actually very reasonable, okay? They also have a version in Spanish, in case you were wondering. And yeah, it seems like there are more words, stop words in Spanish. So exercise 7, filter out all the stop words in the first review of the Yelp review and print out the answer. Additional, print out separately the stop words you found in this review. And if we decide to write down the top words after filtering out the stop words, okay, the first row is telling us what the stop words are. And the second one is what we get after removing the stop words. Super, simple, place, amazing, nonetheless, think, started, salami, etc. So we are getting there. It's getting better, right? So Diego, you think that's the Spanish that they are covering is Castilian? So Castellano? Did you find el coche? Yes, Laura, I was surprised too that it is not the stop word accordingly, but of course we can add it, right? Now, modify the function that you created before to remove stop words before determining the top n-grams. So in this way, you are refining the initial function that you have, and you're basically pre-processing your function so that Fabian, we can manually custom stop words, of course. The stop words is just a list, so you can make your own list. As we mentioned before, if you are a burger restaurant, burger is not universally a stop word. It will be a stop word only in your case because you expect to see it at some point, right? So if we want to look now at the trigrams after adding the stop word list, we find that definitely we can find some of them that are actually meaningful, like I'll definitely back, I've never seen, give place try, staff friendly helpful, Vegas nearly years, Las Vegas trips, half dozen times. So not all of them are meaningful, but some of them are. Yes, we should probably remove also the dots. I agree, Sharon, and the Saxon genitive, the apostrophe S. The other thing that you might want to remove are very uncommon words, right? Not just the very common, but also the very uncommon that probably they are not representing the sentiment of the majority of the reviews. They are just not, they're very unique. And what you're trying to capture is how your customers are feeling overall about your product. So up to this point, we have focused, sorry if I go a little fast, but this is a very long case. And, you know, I would like to, but at the same time, I think you can follow it along and you can go and review it without too much difficulty, because all of this it's quite intuitive. And you are a very, very intelligent and smart class. So some of you are experiencing some Zoom issues. I can see your comments on Slack. My connection seems to be good. So, okay, seems like it's better for someone. So let's start now. So far, we looked at data for processing and transforming, methods for processing and transforming our data. So let's start now to discuss techniques to visualize and explore our data set. So we're going to start by looking at words and n-grams that are most common in positive and negative reviews. So we do not reuse many of the pre-processing steps discussed in the start of the tutorial because they are already included as part of existing packages. In a serious project, one will often customize this pre-processing to some degree, but we are doing this just to speed up things. Palatable edibles, nice, Garrett. So we start by getting a list of the most common words. And these are the most common words that have already been processed by the get top n words. This is the count vectorizer can help us on this. So the top word is place, good, food, just, like, and so on. And this is a bar plot that represents the occurrence of each one of the words. Now, let's see how this changes when we look at positive reviews versus negative reviews. So we are going to divide the reviews into positive when they are 3 stars or more, and bad when they are less than 3. Let's make a bar plot of the top 20 words for each case. And we are asking if it's any different from the looking at the data set overall. So we are going to call good reviews anything that is larger than 3, and bad anything that is larger than 2. So for good, we can see that the top words are place, good, great, food, like, just, time, nice, love, delicious. All of these are not surprising, right? What about the bad reviews? I mean, food is still there, just, place, good, still there. Service, really, sad. When you start saying words like that, it means that probably there was an altercation. Do we have some tools for detecting reviews with irony? I think we do, actually. If you look at the way that even Siri starts using irony, I do believe that there is at least some sequence of words that might be interpreted as irony. So we can see that some words are present in both still, right? Like good, place, and food. So still not that useful, although we have seen some new entries that are actually suggestive that even just by looking at frequency of individual words, we are seeing some signal that we are starting to capture something, okay? What about in bigrams and trigrams? Do we see that they are more useful if we look at the most common words? Well, the first ones are for the good reviews. Sorry, this is for the bad reviews. Customer service, tasted like, looked like. Typically, when somebody talks like that, they are not 20 minutes. People don't comment 20 minutes when they are about to say anything good. Don't think happy hour. Well, that's minutes later. So a lot of times people talk about time when they are having a bad experience with it. Either they were made wait for too long, or so. Let's look now at the bad reviews, but the trigrams. Took 10 minutes. Ce n'est pas. So there are some French as well. Seated right away. Great customer service. Door opening, closing. Worst customer service. But now you start seeing also some dishes listed, like chicken tikka masala. So it's Indian restaurant. French onion soup. Also here we have also, this must be a very eclectic restaurant. Manor Motor Lodge. And I'm not sure. And now let's look at good reviews. Well, really good, 130. Customer service, 120. Make sure, 117. Also notice that the bad reviews seems to be many more compared to the good reviews. Oh, wow. In this case, notice that the word frequency. So it seems that either positive reviews, they use a larger vocabulary, or there is a larger number of negative reviews. And these are the trigrams from the positive reviews. Great customer service, some recipes again, sweet potato fries, definitely recommend the place, highly recommend the place, staff friendly, helpful, service great food. Yeah, so definitely here we can see a definite improvement. So we can see that things are starting to be helpful. Look at the 5 most important bigrams for bad reviews. Yeah, we are about at time. We started a little bit later. I will ask for advice to Oscar and Monica if we can have 10 more minutes, at least to go through over it, and then we can you can keep exploring. It's a very long case, as you could all tell.
Yeah, it's okay. It's okay, Professor.
10 more minutes?
Yes.
Yeah.
We can
Okay.
definitely do that.
I know we're all hungry.
Yes, just come on, guys. We can do this. 10 more minutes.
Okay. So yeah, we discussed about this 20 minutes, 5 minutes, 10 minutes. That's typically an indication that time was a concern. Exercise 9 says, you might have noticed that many of the important bad bigrams included the word like or just like. When you're making a comparison, I pointed out when we were seeing it, it's typically you're saying that it tasted like a bad thing. It looked like a thing that I don't want to see. So there are probably some parts that we might want to isolate out of context. Also, you might be tempted to isolate, you might want to isolate positive reviews when language that is very complimentary is used, like great. The word great, notice they did not appear in the bad reviews. Building on the previous question, we know that most of the most important complaints can be completely observed by looking at bigrams or trigrams. So what you can do is you might want to perhaps have a 4 grams or write down a processing step. For instance, try to avoid bigrams that are followed by a specific word in the same sentence. I would probably try to write a negative review. For instance, I would probably write the burger was cold or the burger was served cold. If this were a common complaint, the most important bigrams might include was cold or served cold, which doesn't tell me what was served cold. A simple fix could be to actually consider was cold as a single word. In that way, you are saving one comparison, okay? But this will require a lot of effort to go through all of them. Another way would be to recognize the words like was are always going to be a problem in this context, as they separate the important noun from the subject. So perhaps considering was as a stop word, right? So removing stop words we can become very aggressive. Again, as I said, it's a list that you can always expand. Then there are regular expressions. Regular expressions is that many times you have some expressions that are a complex concatenation of words, and that you keep seeing regular patterns. And in Python, there are some modules that provide some regular expression matches to text. Regular expression are a deep subject with some documentation here. I will let you explore this more into this, but let's look at there was an interesting way to cook bread. This character, okay, indicates the word not, because what you are saying here is that really it was not an interesting way, because interesting is in quotation marks, right? So the pattern should look at that instance, right? So that was an interesting way to cook bread. Or for instance, here you have a sentence with several typos there. And then perhaps you might want to fix it because it can be a consequence of badly imported text or just a mistake. Another thing that you can do is to use the function re.split to split the first Yelp review into a list of its constituents words, and then use the find all function to search the first 30 reviews for the number of times that they contain the word food. This is not necessarily the most important task that you would have to. However, it allows you to really separate the list of the constituents words. And then using regular expression, find the percentage of review in the top 500 review that have numbers in them. That's another interesting statistics that you can be looking at to find out, okay, how many of them are complaining about time? Remember that was one of the issues. We found that over 32% of the reviews were indeed affected by this. Using the above as a template, write a generalized function that can extract the first word following good. Don't forget to include default behavior for when the word doesn't appear in the sentence. And so what you can do here is you can add the star to indicate that whatever after can be included. So the next word after good is burger. So people are actually commenting favorably about the burger, but also you will have burgers, thing, size, day, and so on. All of these are words that follow up, right? And these are some of the things that we notice about this. People like to talk about good burgers, and this appears 5 times in the first 300 results. And a large number of the results are useless and they are not really informative. And good is something that is not necessarily telling you the most important part of the review, in other words, but is used so commonly that somebody might almost consider using it as a stop word because it's not telling you too much in terms of what comes after. And this is why part of speech tagging can actually help using the word in a more appropriate context. And is, for instance, by deciding the function of the word, whether a word is a noun, a pronoun, an adjective, and so on. And is to identify what words you want to focus on. For instance, you might want to focus on adjectives rather than on prepositions or articles that frankly do not work. So doing it by hand can be very complex and very time consuming. We had to do it all when we were in school, analyzing simple sentences and doing grammar and syntax analysis. However, to do it automatically would be indeed very convenient. And for this, we have the function POS tagging, which means part of speech tagging. And yeah, so we can see, for instance, even in a simple phrase, we can see Natesh is a common noun, is a verb, having is a verb, etc. Okay. And of course, for each tag that you assign, there is a documentation because it also tells you the type of verb that you are using and so on. Last exercise asks you to write code for, again, this is definitely a long case that I encourage you to go back. It's asking you to find in the first 500 reviews that contain a number or a cardinal using position parts of speech tagging only. The tag for a cardinal means a number, is CD, okay? and ask you how many of the reviews have at least one number. And we find out that 56.6% of the reviews have a number in the top 500 reviews, which probably is a sign that there is a consistent number of reviews that have issues with time. And finally, use parts of speech tagging to find the word following good that has an interesting tagging. So expressions that things like a cardinal after the word good is not going to be helpful. But if we know that 45 then comes after a noun, then we say good 45 minutes. And at times, yeah, words that follow are not telling you the whole story, because you might have words that come before, like not good, right? So a function that extracts only the interesting parts of speech, for instance, we look at things like, if we tokenize this sentence, this is a good burger, but I prefer pizza, we'll isolate burger and pizza if we use any of these tags, okay? And next, a function that extracts some of these interesting words that follow the word good. So in this way, we are getting rid of the words that are not very useful, like 45, etc., but we are choosing just the next significant word. So good burger and pizza. And then, of course, adjectives, because adjectives can really tell you a lot about sentiment analysis. And so, for instance, we have good, we said that appear both in positive and negative reviews. Bad appears in 78 reviews. Probably some will be positive when we are saying that something is not bad. But then we have great, few, first, many, same, new. So there are a lot of these adjectives that can provide context into term analysis. Words like disappointed, awful, horrible, and rude appear almost only in bad reviews, while words like that are enthusiastic, as I was mentioning, like favorite, great, fantastic, amazing, appear only in good reviews. Words like small and new can appear in both, because they are obviously not judgmental. They are not, you're not passing a judgment on that. Different also can appear in both reviews. And it really depends on how people appreciate variety. So the major takeaways of today's case is that, yes, today's case was not hard to understand, but complex. There is a lot going on in text analysis. Text can be complex, and we have learned to dissect a document by identifying sentences as part of a review, then looking at words, looking at combinations of words. Once we did that, we said, okay, well, what are the most common of them? And how can we extract important features like type of words as parts of speech that can help us better clarifying the role of each one of those words. And using them all together can actually help us extracting useful information from reviews to understand, even from large amount of text, some of the dominant issues. Thank you for your patience. This was a little bit of a vocal marathon for me. I don't like to speak that much. I usually like to interact a little bit more, but there was a lot to analyze, and I wanted to at least go through it so you can have a navigation map for when you go and experience the case again. Thank you all. It was a long morning. We battled through together and we learned a lot.
Thank you very much, Professor Gavino. Muchísimas gracias. Y sabemos que todos ustedes tienen mucha hambre y el profesor también. So,
También.
Let's go and grab something to eat. Nos vemos entonces en las team meeting. Recuerden que es bastante importante. No se las pierdan. Va a ser muy, muy importante que estén porque ya comenzamos con nuestros proyectos, ¿de acuerdo? Es importante que estén. Nos vemos.